Welcome to this physics lesson. Today, we are applying the rigorous scientific method to a classic investigation, the physics of the simple pendulum. Have you ever stood in a clock shop or watched a playground swing and noticed that some pendulums seem to move with a slow, majestic sweep, while others flutter back and forth quickly? Is it the weight of the bob, the angle of the swing, or perhaps the length of the string itself? Instead of relying on intuition, we're going to use the scientific method to isolate these variables and find the truth through experimentation. The first step of the scientific method is observation. When two pendulums are released, the one with the longer string appears to take more time for one complete swing. This leads to the second step of the scientific method, which is to frame a scientific question. Does the length of a pendulum affect its time period? To answer this question, we must formulate a testable hypothesis, which is the third step in our scientific method. We'll also clearly define our variables to ensure a fair test during our experimental design. Our hypothesis is a specific prediction. If the length of the pendulum increases, then the time period will increase. Here, the independent variable is the length of the pendulum, as this is the factor we are intentionally manipulating. The dependent variable is the time period, which is what we are measuring. To keep it a fair test, our control variables include the mass of the bob, the release angle, and the type of string. In step 4, we move into the laboratory phase to conduct the experiment. We'll test 5 specific lengths from 20 centimeters up to a full meter to observe the mathematical trend in our results. We carefully adjust the pendulum to lengths of 20, 40, 60, 80, and 100 centimeters. For each trial, we measure the time taken for 10 complete oscillations to reduce timing errors. Then divide by 10 to find the time period for a single swing. As you can see from our recorded data, there is a consistent increase in time as the string gets longer. Step 5 is data analysis. We'll transform our raw numbers into a graph to visualize the relationship between length and time period. The graph makes the relationship unmistakable. As the pendulum length increases, the time period rises steadily. This indicates a clear positive relationship between the two variables. We've observed, tested, and analyzed. Now we reach the final step of the scientific method, drawing a conclusion based strictly on the evidence we've gathered in our experiment. Our experimental results strongly support the hypothesis. Increasing the length of the pendulum does indeed increase its time period. By following this method, we've replaced guesswork with evidence-based facts, demonstrating how the laws of physics can be systematically uncovered through careful investigation. Now that you've seen the method in action, it's your turn to think like a scientist. I'm going to give you a new problem to solve using the same experimental setup but a different variable. Are you ready? Your challenge is to investigate whether the mass of the bob affects the time period. You'll need to state your question, form a hypothesis, and identify your variables correctly. Remember, in science, we seek the truth through evidence. I'll see you in the next lesson where we'll dive into the results of your mass investigation.